Hi, welcome to today's video about exo-Neptunes. These are Neptune-sized planets around other stars than the Sun. In this picture you can see two beautiful Voyager 2 images of the planets Uranus and Neptune. These are the two Neptune-sized planets in our solar system. They're also called ice giants. You can see a diameter around 50,000 kilometers. Planet Uranus is the bigger of these two by size, and the planet Neptune is the bigger by mass. A mass of 17 Earth masses. And since they're in the outer solar system, they have an orbital period of 84 years for Uranus and 165 years for Neptune. This is a comparison of Earth and Neptune. Neptune has a diameter of over 49,000 kilometers. That's 4 times the size of Earth, and the surface temperature is minus 201 degrees Celsius. This is called the Neptunian desert. That's the fact that there are no Neptune-sized exoplanets in close proximity to our star. This Neptunian desert has a shape of a triangle. And the reason is so close to the star, there's an atmosphere loss of these planets. However, you can see there are some exceptions. One exception is this planet NGTS 4b. NGTS is the Next Generation Transit Survey. In this picture you can see the 12 automated telescopes. This group of telescopes is located in the northern Chile. This is the system NGTS-4. It's a K-star. You can see here K-stars are a bit smaller than the Sun, which is a G-star. And you can see the planet NGTS-4b. Here you can see comparison the orbit of Mercury. This planet has a mass of 20 Earth masses, so it's more massive than Neptune, but it is also 20% smaller than Neptune. That makes it a sub-Neptune. The orbital period of this planet is 32 hours. The system is 5 gigayears old, 5 billion years. This planet has an atmosphere, and how can such a planet exist? There are two possibilities. One is this planet could have a massive core. The second is this planet migrated close to the star, but later when the star was less active than at the beginning. It's a beautiful artist image of a sub-Neptune. These are planets that are smaller than Neptune by mass or size. So typically these planets have a size less than 3 times that of Earth. And one thing that is known about sub-Neptunes is they are more common than Neptune-sized exoplanets. There's another planet, TOI 849b. It's a potential Chthonian planet, which is a planet that has lost with a stripped atmosphere. This planet is very massive, has a mass of 41 Earth masses, which is almost half a Saturn mass. It has a very high density, 5.5 grams per cubic centimeter. But it's smaller than Neptune. The orbital period is 18 hours and the surface temperature 1800 Kelvin. There's another theory how such a planet can exist, can be produced, and that is by a giant planets collision, by a collision of two big giant planets. This big planet orbits a G-type star like the Sun at a distance of 741 light years, and is a very interesting target for the James Webb Space Telescope. This is another planet, LTT 9779b. It's an ultra-hot Neptune, also called Hoptune. It has a mass of 29 Earth masses and a much lower density of 1.5 grams per cubic centimeter. Orbital period is less than 1 day. And there was no tidal orbital decay found for this planet. So its orbit is stable despite being so close to the star. Its surface temperature is around 2300 Kelvin. And the Hubble data suggests that composition of the atmosphere of water, carbon dioxide, and iron hydride. This planet also orbits a G-type star, a distance of 264 light years. This system is quite young, with age of 1.7 billion years, and that's why the luminosity is just 70% of that of the sun. There's another interesting system, a multiplanetary system, Corot 7. It's a binary of a G-type star like the Sun and a red dwarf M star. This is located at 520 light years distance, and the nearest closest planet to the star is Corot 7b. It's a super-Earth with 6 Earth masses. This could be a lava planet, and its orbital period is just 20 hours. And these are the other two planets. These are Neptune-type planets. One is Corot 7c with 13 Earth masses and orbital period 3.5 days. And the second is Corot 7d with 17 Earth masses and the orbital period of 9 days. There's another interesting planet, that's TOI 5678b. TOI means Test Object of Interest. TESS is a satellite that makes an all-sky survey for exoplanets. This is orbiting a G-star at 539 light years distance, has a mass of 20 Earth masses. And one thing which is known about this planet is that it has a large helium and hydrogen layer and a low mass core. Its period is 48 days. The transit lasts 7 hours. This planet has an eccentricity of 14%. And the current theory is that it was formed further outside and then migrated inwards towards the inner region of the system. This is Gliese 436b. It is a hot Neptune orbiting an M star. M star is a red dwarf at 32 light years distance. And this planet has a mass of 21 Earth masses and eccentricity again of 15%. Orbital period is 2.6 days. And in this picture, you can see the loss of hydrogen from the atmosphere due to the radiation of the star. There's another artist image of an interesting star. There's an M star red dwarf, K233. It is located at 456 light years, has 57% of the sun's mass. So among the red dwarfs, this is a more massive star. This is a very young system with an age of just 10 million years. It's in its pre-main sequence phase, and it has many spots. And the rotation period is 6.3 days. This is a known fact about stars. The younger stars have a shorter rotation period than the older stars because over time the stars lose a bit momentum to the stellar winds, and the rotation speed of the star slows down. And at the left you can see this super Neptune K233b. This is bigger than Neptune in size and mass. That's why it's called a super Neptune. This is an overview of the system K233. You can see its size. It's a very small. It's a very planet is very close to the star, but the star has also much less luminous than the sun. For example, you can see the comparison the orbit of Mercury. This planet is just at a distance of 0.04 AU. 1 AU is Earth-Sun distance of 150 million kilometers. So this means it is just at a distance of 6 million kilometers. Orbital period is 5 days and the surface temperature 850 Kelvin. This is how such a planet could look like, a super Neptune. Its size is 5 times that of the Earth. And the mass is not known yet. One other thing is known, that this planet has still a circumplanetary dust ring. And probably these kinds of planets have many moons. This is what you really want. That's a nice image of the system HR8799. And this is a bigger version of our solar system. The star is bigger. It's an A star with 1.4 times the sun's mass. And the giant planets are also bigger than Jupiter. These are called super Jupiters. There are 4 of them in this system. And check out the other video episode 3 of the giant planets if you're interested. These planets have a mass of 6 to 9 Jupiter masses. And this is what you really want. That's direct imaging using a coronagraph. The coronagraph blocks the bright light from the star, and then the planets become visible. With this method, you could take spectra of the planets directly, and the future space telescope, Nancy Grace Roman Space Telescope, will also have a coronagraph. This is a nice picture of the building of the Next Generation Transit Survey at the Arenal Observatory in Chile. In the background, you can see at the left the domes of the Very Large Telescope, VLT, and the right is the VISTA telescope, another interesting project. That was today's video about exo-Neptunes. Thank you for watching. Have a nice day. Bye-bye.